practice for ILS26, right?
Over the past 6 years, the Project Magenta software range has expanded and become more type-specific, recently obtaining both JAR Level 2 and FAA approvals. The missing link was the aircraft systems side, and last year PM Systems was introduced to fill that gap. PM Systems is running on a PC that is linked to Microsoft Flight Simulator via WideFS. The only additional software is the I/O interface software that allows you to set the offsets relating to PM Systems to the corresponding input or output. In the following example we are using fidget cards, but PM Systems will work with almost any I/O hardware solution. The maximum inputs available on this particular fidget card is 16. Therefore, 6 cards in total are required. These are connected by 2 4-port powered USB hubs. Each card was given an identifier A, B, C, D, E and F. Each switch on the overhead panel was assigned a number according to which I/O card it was going to be connected to. These were also logged on a diagram and a spreadsheet for further reference. These particular I/O cards required a powered input, so one side of all switches is supplied with 12 volts, and the return other side of the switch connected to the corresponding input of the card. Each card has a ground. Thus, when a switch is placed in the on position, the circuit is completed. In order to keep track of the wires, in fact over 1.2 kilometers of wire were used on this 737 overhead, a colour-coded system was used. Blue for ground, brown for the positive switch supply lines, and pink for the positive return to the I/O card. With the outputs, a similar principle was used. Each annunciator has two 2.3 volt LEDs. 2 LED 64 boards were used. Again, this was split into X and Y boards to identify the output. Annunciator colours were defined. Single blue required only one output, dual state valve lights required 2 outputs to give the dim and bright states of the 737 valve positions. Again, colour coding was used to track the outputs of each card. The next step is setting each input and output so it can communicate directly with PM Systems. This is the almost completed 737 panel. All the I/O has been connected. PM Systems is running. Microsoft Flight Simulator is also running on the network. This is a simple 2-position switch. It has a defined offset in PM Systems, but actually offsets are almost a thing of the past now for the end user. Here, PM Systems has provided the name of the switch, and I'm just selecting the center fuel pump number 1 from the drop-down menu. I'll allocate it to input number 20. You can see the value going from 0 to on the left-hand side of the screen. I also use the PM Systems software graphic to check the operation. There are more complex switches, like a 3-position switch, or a 4-position rotary. Each position on the switch has a given value in PM Systems, 0, 1, 2, 3, etc. The overall authority remains with PM Systems. It provides the logics, it will determine if a given condition is available or not, and thus indicates that condition on the overhead panel. Using the PM Systems software graphic becomes an essential tool to checking and cross-checking the logics.